All right, we got another example here on the distance formula that we're going to use the distance formula to prove that the diagonals of a rectangle are congruent. So the diagonals of a rectangle are congruent, something that we looked at earlier this year, and now we're going to prove that they're congruent using the distance formula. So that sounds maybe scarier than it actually is. So here's a rectangle, and I have generalized points here, and this is on the coordinate grid, and I have one vertex of the rectangle is 0, 0, the origin. It's just going to make things easier if it's along the x and y axis. So let's call this point 0, 0, and then we're going to call this point straight up here 0, b. And this b can be any number. It could be 1, it could be 2, it could be 7, it could be 30. It can be any number. And it's straight up because the rectangle will be straight up from the origin there. And then if I come straight over this side here, notice I have to have a right angle in a rectangle because that's what a rectangle is. This coordinate over here is going to be a. I'll go so many units over this way, and that a could be 5. It could be anything, but the y value will be 0 because I'm right along that x-axis here. So this a could be any number. And then if I go up to this point C here, this is going to be a comma b because I went so far this way a, and then I have to go straight up, so that a is not going to change. And then I went straight up to b, so this distance from E to C straight up here is going to be b. So these are just generalized coordinates for a rectangle on the coordinate plane here. A and b can be any numbers, and you call a and b whatever numbers you want to, as long as these b's are the same because they're both b's, and these a's are the same because they're both a's. You're going to make a rectangle. That's what it will be. So this is just a generalized, and this is what's going to provide our proof because it doesn't matter what a and b are. We're going to have a rectangle. We want to prove that the diagonals, so from 0, 0 to AB, and then 0B to A0, we want to prove that these two segments, or these two distances, are the same, or that they're congruent. So we want to go from 0, 0 to AB. We want to compare that distance to the distance of 0B, A0. So we're going to calculate two different distances here. And we're going to use the distance formula. Here's our distance formula. We take the difference of the x values squared plus the difference of the y value squared. The first one I'm going to find here is 0b to a0. So I'm going to go from this point, 0b to a0. What is the distance between those 2 points? I have to assign these values as x1, y1 and x2, y2. And when I do that, I get this formula once I've assigned that. So I'm calling x1 or x2, and then the other one, x1 or x2. In this case, we have x2 and x1, 0 minus a, which is right here, squared, plus, and then we have to take the difference of the y values. The y values are b and 0, so b minus 0. So I've just taken these values and plugged them into the distance formula. 0 minus a is negative a, b minus 0 is b, so we're left with this right here. Negative a squared means negative a times negative a. Negative a times negative a would just be a squared. And then b squared would just be b squared. So the distance between these 2 points, 0b and a0, from here to here, will be whatever a is squared plus whatever b is squared, and then taking the square root of that number. And we can't simplify this any further. This right here is the distance from 0b to a0, and that will depend upon whatever the coordinate values of b and a are. So we simplify this as much as we can. Now we're going to find the distance between 0, 0 and ab using the distance formula. So we're going to do the same exact thing here. So plug those values in. We get 0 minus a, 0 minus a, and then 0 minus b from 0 minus b. Difference of the x values squared plus the difference of the y values squared. 0 minus a is a squared, we did that before. 0 minus b is negative b. Negative a squared is positive a. Negative b squared is positive b, because a negative times a negative will be a positive. Notice that when we simplify these two, we end up with exactly the same expression. Therefore, these two distances will be the same, and it won't matter what we plug in for a and b at the beginning. You want to try that out, say call B7 and call A8 and then plug them in, and you'll get exactly the same distances. It will work every single time. And this is that generalized procedure to prove that.